Alright, so in this video, we're going to go over how you actually design these abstractions in terms of like what are the files and what are the contents of the files. So we're going to go kind of like from scratch. So I'm going to actually build a class for you from scratch in here that is different from RVector, but then we're going to go back to RVector for the remaining parts of this week and dig into all the different features of a class using RVector. But I thought it'd be helpful to look at a simpler data structure and build it from scratch in this video, and then going back to the RVector will make a little bit more sense. So when you write a class in C++, typically, and I'm explaining this to you because pretty much all the time you see this is how it's going to look, so I wanted to make sure you saw it this way, which is that classes are written in two files. One is called a header file, and that's the one with the .h, and then the other one's called the implementation file, and that's the .cpp file. So if you make a class like we're going to be making here today, I called this class random bag, and it's just a class that it keeps track of elements, and it has two behaviors that it can do. It can add something to the bag, and then it can randomly remove something from the bag. So it's just like a really simple data structure. You could implement it with anything under the hood. We're going to use a vector to implement under the hood so that we don't have to manage memory in this example. But that's all this class is going to do. So I'm going to show you how to build this class using the two separate files, and basically it allows the user to have access to the header file, which basically explains like the functionality of the class without having to dig into the implementation file, which has all the details of how the functions are implemented. So when a client uses your class, they just include the .h at the top, which is what you're doing all the time and you've seen it, but maybe you haven't thought about it. So let's start by building the class. It's a fairly simple class, so it'll allow us to kind of start, from just a blank file and add everything that we need. And then I'm going to end this video by showing you how to combine the header file and the implementation file into one file, which is how we're going to be writing our classes in CS251. There's a couple reasons for that. One, it simplifies things to just have one file that you're submitting, but also if you write templated classes, you have to include it. It all has to be in one file. But generally, you will see a lot of code written with a header file and an implementation file as two separate pieces. So let's start with that. So let's start with the header file. So the header file is going to basically declare everything in the class. So it starts with the class definition, and it is a keyword that's used to indicate that this is going to be a class in the file rather than just like a typical file with main. It's followed by the name of the class. So we're going to name our class random bag. One thing that you have to include at the end of this class code block is a semicolon. You don't add semicolons to a lot of code blocks, but you have to at the end of classes, so don't forget it, otherwise you'll get compiler errors. Then you separate out the interface and the implementation with public versus private. So private, remember, is anything that the user doesn't have access to, and the public is everything that the client would be able to access and use. So that would be kind of the interface. The public interface can include any public functions that you would like the user to be able to call. Most of the time this includes constructors by default, at least a constructor or two. And then typically, if the user needs access to the private member variables, it'll have getters and setters. But then any other function, pushback, find, insert, erase, any of those functions are public. The private implementation is all the stuff that you don't want the user to have access to. So it's definitely all the private member variables, but you'll also want to include some private functions that help your code, particularly like help decompose your code, but that you you don't intend for clients to use. So here's some member functions that we're going to implement for the random bag class. We're going to have an add function, which basically just adds a value to the bag. And then we're also going to have a remove function, but it's going to just be a function that removes at random some element from the bag. So remember, this abstraction is basically like, if you wanted to randomly pick a number, this type of abstraction could work. So it's just a bag of numbers that you don't really have access to, except for removing one randomly. We're going to have a couple of helpful functions like isEmpty and size, which will help us, manage the abstraction a little bit. Those are very typical functions in all abstractions, size, isEmpty, because they help the user keep track of what's going on inside of the private part of the function. So we have one private member variable, also called a data member, and we're just going to keep track of everything that's added in a vector. So all that's going to be in the private portion of our code is a vector of integers, and we're going to use the private member variable elms for elements. I'm just going to say the word elements when I refer to this variable, because elms is like awkward to say. So this is our header file. So the header file, with comments added, can kind of provide the client with everything they need to know about the function. You'll see that something that's added is this statement here at the top. You'll also see this in the our vector class. I'm totally blanking on what it says at the top. Pragma once. Pragma once, or this like if and def garbage, is basically there so that you can include headers twice. And so it's just this like kind of clause that has to be at the top of every header file, so you'll see it. This is like the older version. It's used on some systems, and then Pragma once is a little bit newer and works across systems. So we are going to now write the implementation file. So remember, both of these files are needed when you separate out your class into two files. The first thing you need on an implementation file is the include statement, just the same as you would need if you were going to include this class in any main file that you're writing, right? So I have a little snapshot of the class over here so that you can remember what it looks like, but we're going to just start building the implementation file. So in the implementation file, you're just going to write all your functions. And so the first thing that you'll notice is when you separate out the functions, and I wanted to point this out in case you're, seeing this in other places, that you see these files separated. One of the big differences that you'll notice is that you have to actually have a scope resolution operator, which allows you to scope the function that you're writing in the implementation file to the random bag class. And its syntax is just the class name : in front of any of the member variables. Otherwise, all this function has in it is a definition of the function, right? So the first thing you'll see is that we write the add function. There's nothing too crazy. When someone adds something to the random bag, you're just going to push it back into the elements vector. And oh, this is capitalized. I'll need to fix that. That should be lowercase. The elements vector is a private member variable, so you have access to it in the class. So when you're in the class, you have access to this. You don't need to write randombag.elms or something else that you might imagine that you need to do. You just have access to it. It's kind of like globally available inside of the class definitions. If you didn't have this in here, and again, this is only the case when you split the implementation file and the header file, then the compiler would be confused. So it would think that you're just making a free function that has nothing to do with random bags. And so you'd get compiler errors with scope if you wrote it this way. So you need to include that scoping in there. It basically tells you that you're inside of a random bag object when you're calling that function. Okay, so let's write the random remove function. So it's going to use a random number generator, and so we're going to call the myrandom.h file, which has access to a random number generator, and that's where random integer is. So this includes the random integer function, which you're all familiar with probably. That's really barely visible. But all the random remove random function is going to do in this simple case is it's going to randomly choose an integer. It's going to access that element from the elements vector, and then it's also going to remove it from the vector, so it's no longer there. And then because you have an integer returned, it's going to return that random number that it picked. So remove is written, and as you can see, it has those same features. It has the scope here because it's scoped to this element. Okay, so now let's write size and isEmpty. Size is a really easy function to write in just about every container or abstract data type that you write. All it's going to do is it's going to return the size of the vector. In our vector case, we have a C array, so we kept track of the size ourselves, so it just returned the member variable size. But in this case, we're just going to call the public member function of the elements array. And then isEmpty is also easy because we already wrote size. So if size is 0, then the random bag is empty. So this is actually calling this function, and it's checking if it's size. So that's how these functions talk to each other. They can call each other inside of the implementation. And you don't need to scope them because they are already scoped properly in the class itself. So it knows what size you're talking about and knows which element vector you're talking about. Went backwards. Hold on one second. So now we have size and isEmpty written here. And so what we can do is we can actually make use of that and use it inside of the functions we just wrote. So here we're using elems.size as our endpoint for the vector or for the random number to generate. But instead of doing that, we can actually just call size now. Because we just wrote it, right? So instead of calling another container's member function, we can just define it one time and then use it here. So we're going to update this to be size. And so you can see here, now we've used size here instead. But another thing we could do is, previously we had written, let me go back one so you can see what I mean. Previously we had written elems is empty, but we just wrote is empty here, right? So we can go ahead and update size and is empty everywhere and use the member functions that we wrote inside of our member functions, right? So that's kind of how this all works. You'll also notice that we made these constant, and this is a way to declare the entire function as constant. So we're not declaring one of the variables inside the function constant, but the whole function itself is constant. And we're doing that because these functions should not contain or should not change anything about the object. That's just the nature of the function, right? Size function should not change anything, isEmpty should not change anything. So if you have a function that shouldn't change anything, it's good to make it constant so that you ensure that that never happens. So this is our .cpp implementation file. We wrote two simple functions, one that adds to the random bag and one that removes something random from the bag, just to do something simple. And then we also wrote these other two functions that are really helpful to the client and to ourselves because we can use isEmpty, we can use size in order to help us keep track of different aspects of our object. So this leaves us with these two files, the .h file and the .cpp file. These are the header file and the implementation file of the class random bag. Now, this is what you'll probably see most often when you look and deal with classes outside of this class. You'll probably see them separated this way. This is very typical. They would have lots of comments in them, but we wanted to make sure it fit on the screen so there's no comments that describe their behaviors. But this is what you'll see. In our class, we're actually going to combine the two into one file and put everything in the .h file. So it looks very similar, but it's a combination. So you're going to see the class, you're going to see the public and the private, but instead of just listing out the member functions like we did in the .h implementation when it was separated, so here they're just listed as prototypes. Functions are defined there. Because they're contained in one file, you don't have to have the scope declaration to the class, which simplifies things a little bit. The private member variables are in the same spot too. So it's nice for a couple reasons. When we submit your files for grading, we don't have to submit both files. As you're developing these classes, and you're going to add member functions, and you always have to add them in two places, one in the .h file, one in the .cpp file, and make sure they match. So that'll avoid you having to do that. And the big reason that we're doing it is because we're going to write templated classes. And so while we could first start by writing these typical separated files, and then when we do templates we could combine them, we're just trying to keep it a little bit simpler, so we're going to always write our files combined. So I hope this video kind of went through this process of writing out these classes in separate files or combined files, but really just starting to think about how to build a simple class. Keep in mind that for this particular class that I showed you in this example, we did not allocate any memory for the class because we used abstractions that do that for us. So this had a vector under the hood, so we didn't have to call new, we didn't have to manage that memory. It was all destructed within the containers that we were using. In the RVector class that we're going to move to now, you're going to have to handle that memory yourself. So stay tuned for that.